Now everyone should have the handout. Section 1.3 is just called Problem 5. Um, if you just completed Exploration 1-3A, then you can probably do this without watching the video. So if you just did the exploration, I would say stop the video right now, go ahead and do the problem and see if you get the answer. My answer that I got was approximately 633 feet. And again, that was approximate, but it should be somewhere close to that. So what we need to do is we need to estimate the distance that this car is traveled from time t equals 5 to time t equals 25. So first thing I'm going to do is I'm going to figure that out on my grid. So from t equals 5 to t equals 25. So this is the region that we're talking about. And we're talking about velocity on the y-axis. We're talking about time on the x-axis. So to estimate the distance traveled, I would want to multiply my v times my time. And in terms of units, my velocity is in feet per second and my time is in seconds. So if I multiply those together, I should get feet. And again, I always use my units to help me figure out what it is it's asking me to do. So I need to estimate this distance, and I need to do that by using area. By using area, I really need to count some squares. So first thing I'm going to do is I'm going to go through and I'm going to count the full squares. So I've got one full one here, one full one here, another full one here. Now I need to put pieces together, so to speak, to make solids. And I think that this piece that I've just highlighted in blue, if I were to add that to this little smidge over here that I've shaded in blue, I think that could count as a single square. That's not true at all. I did not use that. Sorry, I used this blue one and I used this little piece a little further down. I apologize. So the shaded one that I have now in blue going with the other shaded blue, I think that that's a single square. So I'm going to count that as square number 4. Then when I look on, I can see this that I'm highlighting in green. This square is almost complete. It's just got a little small part missing. And the first thing that I shaded in blue that I'm now shading in green, I think if I add that to the green shaded, I think that gives me another square. I'm going to call that square number 5. And then we have a couple of extras that we need to put together. So what I did is I basically said, well, this last one here that I'm going to shade in red, this guy's almost a whole square. He's pretty close. This one right here. And I think if I can find a piece, say this piece from the bottom square that I've just shaded, if I were to fill that in, that would nicely fit right there. So I'm going to call the reds that I've just shaded, I'm going to call that square number 6. And I have this little white space that I have left over, and I think that this little space, I estimated that to be about 1/3 of a square. And again, that's where estimation is coming into play. So I think right now we have approximately 6 1/3 squares. And now I need to figure out, well, how big is each square? So for each square, let's look at the x-axis first. The x-axis, so the very first square on the grid, going across, the x-axis seems to be 5. And so I'm going to label that on my square as 5. And then the y-axis, I don't know how much that is, all the way up to here is 60. 1, 2, 3. I have 3 sets, which means this must be 20, this must be 40 to get me to 60, which means the y value is 20. So the area of this particular square should be 5 times 20, which is 100, and the units for the square would be feet. So I know I have 100 feet in each square. I have approximately 6 1/3 squares, which means I think that the distance is approximately 633 feet. And that is the end of this video lesson on problem 5.